Okay, here we go. All right. Good morning, everybody. Or I'm not very sure which time zone you're watching this video in. My name is Sagnik Ghosh, as you can see here, and today I'll be explaining or sharing my knowledge with you all about systems. So, a system is a collection of parts and how those parts interact with one another, which make up one whole entity. Honestly, when I heard this definition the first time, I couldn't understand it at all. So let's make it a little more simpler. I've broken the definition down now. So I'm making a claim that we are systems. Now, how can we prove this claim according to the definition? Well, a system is a collection of parts, as the definition said, a collection of parts which interact with one another. So, what are the collection of parts in our own human body? Well, we got our cells, we have our internal organs, we have our numerous body organ systems, circulatory system, respiratory system, digestive system, nervous system, so many, right? Those are the collection of parts in our own human body. That is one criteria fulfilled. One criterion of the definition is fulfilled now. How do those parts interact? Well, this is quite simple to explain. If you have ever touched something very, very hot, you might have your brain has sent you just might have removed your finger at the first out of reflex without even thinking of it. You might have removed your finger out of reflex, and that is the signal your brain sends to your finger to remove your hand or finger from that hot object, because it knows that that hot object is harmful to you, right? So that is a very good example of an interaction of parts. Another example, well, our daily activity of walking. How does walking happen? Well, it's through the coordination of our legs, our hands, our eyes to see where we're walking, right? Although this guy is jogging here, same principle. And another example I can give you is when we are hungry, our stomach sends signals to the brain to signify that we are hungry, to tell the brain that yes, we need food now. But after a point of time, your brain tells your stomach that no, we don't need any more food, we're done here, right? So that's another example of an interaction of parts. Now, the collection of parts and the interaction of parts should make up one whole entity. Now, what is that entity? Well, us, human beings. So there you go. There we have defined and justified why we are systems. Let's look at some more examples. Now, I want you all to try. You can pause the video now. You can try have a go at all these things. What are the parts in this image, or actually system, and this system, and so on. Have a go. Right. So I'll assume you would have paused the video. So these are the parts of, so this is the solar system, and the parts in the solar system are planets, asteroid belts, the sun. I didn't write it here because of the lack of space, but you get the idea. And honestly, in terms of interactions, there will be like a million interactions that can happen inside the solar system, but you understandably I've written only one or two. So please don't feel disheartened if your answer is not taken. That does not mean that you didn't understand the subject. It just means that I have a lack of space in my PPT. All right. Heat from the sun, gravity of Jupiter, which keeps asteroids from colliding with Earth. Right. So those are an interaction of parts. So here, a planet Jupiter is interacting with the asteroids, or the gravity or the heat from the sun. It reaches us on a daily basis. That's why we have sunlight, right? Or that's why we don't freeze to death. And in the second part, well, we have an atom. So the parts of an atom are electrons, protons, and neutrons. There are many more, but you get the idea. Then we have the positive charge of attraction, the positive charge which attracts the negative charged particles or the electrons. It makes the electrons stay within the orbit, right? So the charge emitted from I'm sorry, I should remove this here, right? So the positive charge emitted from here is so strong that the electrons are unable to go out of an orbit, right? And this is an interaction between those parts, and the whole entity is an atom. And you can see here in terms of a tree, I'll explain the tree in a little more detail because I'll be using the tree's reference later on in the video as well. So branches, leaves, trunk, roots, these are the parts of the trees. Branches direct where the leaves will grow and get the most sunlight. That is an interaction of parts. So branches are interacting with the leaves, telling them where to grow so that you get the most sunlight, right? And the whole entity is the tree. And you can just have a look at this. This is marine forest. Okay, let's move on. Now, a system is further divided into two parts, which are known as flows and storages. Let's look at what they are. Flows. Now, for all of you who may be hungry, maybe it's a time to pause the video now and grab some food. That's of course a joke. So flows are divided into two parts, again, inputs and outputs. But these are fairly simple to understand. Inputs are the ingredients used by the system and its parts to create outputs, right? So since I've said ingredients, let's take the literal meaning of it. Vegetables, spices, they're going to use all these raw materials, sort of manufacture it, cook it, through these utensils, and these are the parts of the system which sort of create the output which we want, which is here, the food, right? So ingredients, the utensils used to make the which we use for making the food, and the food itself. And here's some more information. Well, the controlled variables can be the utensils you are using to make the food. Here, these can be the controlled variables. Inputs are the independent variables because they keep changing throughout the progression of making food, of you making food. And the outputs are the dependent variables because whatever is the output is always dependent on the input, right? Or on the ingredients. Now you can compare this with functions in math, So in functions, what happens when there is f of x equal to y? Y is always dependent on x. So the value of y will always be dependent on x, right? So you can think of inputs and outputs in that manner as well, right? Okay. Now let's look at it in terms of an actual system. So same thing, okay? These are the ingredients, these are the parts of the system, and this is the output. Okay, remember that structure. So the inputs in a tree, okay? Oxygen, carbon dioxide, rain, sunlight. Now all these parts of the trees, they manufacture all these raw ingredients into, again, oxygen, CO2, because all living organisms respire, glucose, which they use for their own energy. They also in the reaction for respiration, you'll find that they also respire water, and of course fruits, which are the outputs of all these things. So you get the basic idea now that ingredients, so the inputs are the ingredients, the cooking utensils are the parts of the system, and the outputs are the dependent variables or the food which we make using our ingredients. Okay. And now, finally, we have the other part of the system, which are storages. This is fairly simple to understand. Parts of the system where energy and matter are stored. And since literally everything is matter, you can classify anything into a storage. For example, this nice looking leopard here, it has energy and matter. Matter, of course, in its body itself, and energy in terms of chemical potential energy, right? Because that it uses that chemical potential energy to run throughout the day to hunt for its food. Same from here, same for this spotted deer. This one uses that energy to run away from that leopard. Although, please, I'm not sure whether or not leopards hunt spotted deer. And these are again the storages: the trunk of the tree, leaves, branches, roots. These are where the energy, these are where energies and this is where energy and matter is stored within the system. Same thing here. In a large ecosystem of, let's say, a very nice looking national park, we have this river here. This river has kinetic energy. It's always in motion. So that's the energy storage. And matter is, of course, the river, the water itself. And you can also consider maybe the rocks within the river or the fish, right? And this can also be a storage in the whole in the solar system, right? Energy and matter is stored here. and of course our favorite mitochondria, which is the powerhouse of the cell. So here energy is stored and this energy is manufactured, and then we can use it for our day-to-day needs. Okay, so I hope you've got something useful out of this lesson. I hope that this was something valuable, and I hope that and this will be a this is part one of a continuing trilogy, I should say. So you should expect another video on the systems aspect quite soon, because we're not done with systems, right? Thank you very much. I hope you enjoyed the video. Like, share, and subscribe if you wish. Thank you.